to meet you. Welcome. We want to wait 2 minutes because the student.
All right.
Are going to log in. Okay. The class is 1 hour. Okay. After the student, you know, coming to the class. The class is science, biology, engineering.
Okay.
What is the class? Is biology or is chemistry?
I'm a chemistry tutor.
Oh, chemistry. Okay. Excellent. Hello, Danny. Welcome. Samuel. Welcome, guys. Stephen, welcome. Matthew, Camila, welcome, guys. Okay, teacher, you can start. Okay, welcome, guys, and join the class and learn. Okay.
Hello.
Hello, Stephen. Okay, teacher, you can start.
All right. Hello, everyone.
Say hello to the teacher, guys.
So today we are going to explain some.
Hello, teacher.
Hello, Mark. And the topic for today would be about the periodic elements, their physical and chemical properties, the different arrangements that they get in the periodic table. We have to learn some topics about how the reactivity changes from left to right or from bottom to top. And all these informations we are going to learn them about step by step. But the thing that I wanted to share with you before learning about the periodic table, we have to know that all the elements that are found by scientists from the moment in the periodic table, there are around 180.
Allá pásame a la abuelita.
Pablo, please put
Okay, so about 118 elements are represented at the periodic table, and they are separated about the discovery that the scientists have found. They can be separated into two parts: the natural elements that are in the earth crust, or in atmosphere. And the second group of the elements are artificial elements. So the artificial elements are mostly the F group of the elements, which most of them are radioactive. These elements, I'm talking about the artificial elements, these elements have some period of time when they decay in two parts in different atoms. So some of them are not part of the periodic table yet, because the scientists are separated in two different groups. Some of them said that if it is only 4 atoms existing of an element, it cannot be part of the periodic table. So there are also 8 more elements which some new scientists at the 21st century have discovered, but they are not yet put it at the periodic table because they have to be approved by the most scientific knowledge known by, for example, the Nobel Prizes, etc. And the elements for the kind that they represent can be a part of the big group of the elements, which are the metals, and the second group of the elements, which are non-metals. Okay, so how can you understand that an element is a metal or a non-metal? It is simply because now we have the periodic table that the Mendeleev has represented to us. So I'm going to show you the periodic table quickly. And all these colors makes the periodic table very beautiful to our eyes, so we can easily remember them. We can start from, we have columns which has this direction from up to down, and we have rows in this direction. So rows, we call them differently the period number. So the period number, which in this periodic table also we have 7 period elements or 7 rows. It means that these elements have different shells in them. So what are the shells? The shells are the number of orbitals when the electrons move around the nucleus, and they change by the different other elements by their number of shells. And the columns represent the valency electrons. So the valency electrons are the number of electrons in the outer shell. So it's number of electrons in the outer shell. For example, in the periodic table, we have the most famous element, which is oxygen. Then the oxygen is in the group 6A. What does it mean in our words? It means that the oxygen has 6 electrons in the outer shell. So it means that it is in group 6. And group A is for the elements which has more than 3 electrons in the outer shell. It means that it will be the group A. But the metals and the non-metals are separated by each other by a zigzag line. Zigzag line, I'm going to draw it in yellow here. It doesn't look like beautiful, like, yes, in black here. This line is the line when we separate metals from non-metals. In the left, we have the metals, and in the right of the periodic table from this zigzag line, we have the non-metals. As you can see, the alkali metals are in the brown line, in the brown column. The alkaline earth metals also are the second element, which is the second column. And then we have the other metals, which are the transition elements, the transition metals. For example, the most famous element here would be for copper, which is very famous. It would be gold or silver, or it will be titanium, which we use in our bodies when we crack our bones. We replace the bones with titanium, which, because all these transition elements, they have a chemical properties related to the other metals because they are inactive. Inactive means that they would not react with other elements such as oxygen, so they do not oxidize with oxygen generally, because some of them can, and some of them do not react with acids, and some of them are very strong. They have high melting and boiling points related to the most active elements, which are the first and the second A group. And what about metalloids? And the metalloids, which are in green, these are some elements which should be considered as non-metals, but they sometimes they occur some metallic properties, such as their high melting points. They conduct electricity. They can form ionic bonds, for example. This kind of properties makes them metalloids, which is in the middle between metals and the non-metals. And the non-metals, which are in blue, is represented by the most famous non-metals, which forms organic compounds, which forms different compounds that we can just remember them in our everyday life. For example, carbon dioxide or sugar. This kind of substances that we use every day are formed by these non-metals. Or sulfur dioxide, which is one of the pollutant gases that our cars produce. Or we can talk about nitrogen, which is gases are famous for their reactivity in air that forms acidic rain. And also we can talk about the other elements, which are halogens. Halogens are also non-metals, but they are the most reactive non-metals in the periodic table, and they are called the 7A group. We are going to talk specifically for them in coming minutes. And the noble gases are the last column of the periodic table, which are all of them are gases, and they are famous for inactivity. This inactivity of them comes from finishing the outer shell or completing the outer shell with electrons. They have completed their outer shell, so generally they do not react with other metals or non-metals, and they generally, this group, do not form compounds. They exist as single elements, generally in atmosphere, or helium, which exists in different galactics or stars. Neon, argon, etc. These kind of elements exist in atmosphere that we use for headlamps for our cars, or making light in different streets, etc. Kryptonium and xenonium, we use them in medicine. We use them to make different apparatus for showing how to make a heal in different people, and which are very famous. But these elements are inactive and they do not react. They do not have chemical properties. I'm going to make some new information about the elements, how they do have this position. For example, oxygen, as I said, is in group 6A, and its periodic its periodic number, it's 2. The number 2 for the oxygen is for the number of shells. So the number of shells for the oxygen is 2. And the number 6 for its group, it represents 6 valency electrons. So 6 valency electrons are in the outer shell. So if we draw the oxygen as the element, it would have related to the atomic number. So the atomic number for the oxygen is 8. It means that the oxygen has 8 protons in the nucleus, and it has 8 electrons. So the first shell can have only 2 electrons, 1 and 2. This is the maximum numbers of electrons in the first shell. And then the other 6 electrons would stay at the second shell by 3 pairs of the electrons. So here we have the 6 electrons. So we can write the electronic configuration, which is very important to show how the electrons arrange in the given element. For the oxygen, we can write simply 2 and 6, which says that the first shell has 2 electrons and the second shell has 6. If we count the number of shells here, it would have 2 shells. The first shell, 2 electrons, and the second shell, 6 electrons. That's why the periodic number for the oxygen is 2. And if you look carefully at the periodic table, all of the elements in their table has some informations. Let's talk about lithium. Here is lithium. So lithium is a metal. Its name is lithium, and the symbol for the lithium is Li. Here we have 2 numbers, the number of 3 and the number of around 7. So we are going to talk about what does it mean, these numbers for all these elements in the periodic table. Mendeleev, which is the first scientist who discovered or created the periodic table, it put all the elements in order of increasing the atomic mass. So he put the elements in order of increasing the atomic mass. The atomic mass for these elements is this high number. For example, for carbon, the atomic mass is 12. For nitrogen, the atomic mass is 14. For the oxygen is 16, etc. So it put the elements in order of increasing the atomic number. So from carbon, it is 12, to the nitrogen is 14, to the oxygen is 16, etc. But in some examples, this order is different. Let's go and look carefully to tellurium and iodine here. If you look carefully here, can you find what is the difference between these 2 elements in order of increasing the atomic mass? Can any of you find what is the difference that I told about? So the question is, as I told about the increasing the atomic mass from carbon to nitrogen and oxygen, what changes from tellurium to iodine? Can you guess what is the change? Okay, no problem. I'm going to the chat. Maybe you write there. Can you write here in chat what is the difference? What does it change when we pass from tellurium to iodine? Okay, I'm going to explain it that. So as I told about increasing the atomic mass from carbon to nitrogen, here in tellurium and iodine, the atomic mass decreases. So it goes from 127 to 126. Or if you make a round, it will be 128 to 126 if we make around the digits. So the periodic table that the Mendeleev discovered or created is very different from this periodic table that we are talking about today. Because if we put the elements in order of increasing the atomic mass, the group numbers would change. So iodine cannot stay at the position of the group 7, but it would stay at the group 6, and tellur would be at the group 7. But if we do this change, there.
Repeat that, please.
Sorry.
Can you repeat that, please?
Can you repeat? A student have some question. Can you repeat the last part?
Which one? These elements?
Yes, sir.
What is the question?
No, I'm about the mass.
Yes. It changes the mass.
Oh, okay. I understand now. I understand.
Okay. So now, what is the order for this periodic table that we use today? The order is the elements are put in order of increasing the atomic number. The atomic number, if you look carefully, increases by natural numbers from 6 to 7 to 8 to 9, etc. Or if you go to tellur and iodine, the atomic number is 52 and the atomic number for iodine is 53. So it changes only by increasing the atomic number for the elements. Now I'm going to make some examples that you would need in different exercises in school or in college. I would work for lithium. The atomic number for lithium is 3. It means that lithium has 3 protons and 3 electrons. But if we look carefully at the periodic table, the atomic mass for lithium is 7. So A is equal to 7. What does it mean? How can we find the atomic number? So the atomic number can be found by neutrons plus protons in the nucleus, because in some elements, maybe on all of them, the number of protons is different by the number of neutrons in the nucleus. So for the lithium, we have the number of protons equal to 3 and the number of electrons equal to 3, but the atomic mass is 7. So for this, we can find that A is equal to N plus protons. If the atomic mass is equal to 7, the neutrons can be found as a number because the atomic number is 3. So by this we can find that the neutrons are equal to 7 minus 3, which makes 4 neutrons. So in the nucleus of the lithium, there are 3 protons and 4 neutrons. 1, 2, 3, 4 neutrons. This is a nucleus for the lithium, and the orbitals and the electronic cloud would be the first shell, where they are 2 electrons, 1 and 2, and the second shell for the lithium would have only 1 electron. So from this we can take an information for this element that the atomic mass is related only to the nucleus of the atom. It doesn't we don't need to find the number of electrons to find the atomic mass. So when we write the symbols showing those informations, we can simply write for the lithium like this: Li 3 7. So this is the square that shows the atomic element of lithium. The number 3 shows the atomic number, which we are going to write it as symbol, and number 7 is for atomic mass, like A. Let's work with another element. For example, aluminium. Aluminium at the periodic table has this number 13 and 27. Can you guess, any of you, find what are the number of protons, electrons, and neutrons for aluminium? You can write on chat, and I'm going to find which of you is going to find the number of each of these subparticles.
Come on, guys, you have to participate in the class. Who have the answer? Write in the chat.
What is the number of protons, electrons, and neutrons in this element? Yes, number 13. What is number 13? So protons is 13. Okay, great, Danny. Okay, number of electrons? Abigail? Neutrons 14. Great. Okay. And number of electrons? Great, Danny. Yes, it's 13. It's 13. Yes, Valeria, I'm going to repeat it again, how we found this number of electrons, protons, and neutrons again. So the number 13 shows the number of protons and the electrons. In each element, the number of protons and electrons is the same. So 13 is for 4 protons and electrons. So the atomic number, which is a natural number, is always protons and electrons is the same. And the 27 is A. So A is the mass, and the mass of the atom can be found only by the particles which are in the nucleus, in the center of the element. But what are the particles which are in the center of the elements? There are protons and neutrons. These 2 particles makes the atomic number. So for the aluminium, the A is 27. So A is equal to number of protons plus number of neutrons. So 27, it's equal to number of protons plus number of protons, which is 13. 27 minus 13 would make number of neutrons. So 14 is number of neutrons in our case. I hope you understood that. So now we are going to talk about what changes from left to right or up and down to the periodic table. I'm going to show you again the periodic table. Okay, so let's go and talk a little bit about the elements in the first column. The elements in the first column are all metals except hydrogen, because hydrogen generally reacts as a non-metal. From lithium to natrium and sodium to potassium, rubidium, etc. So if you go down to the group, the reactivity of metals increases. The reactivity of metals increases. It is because the elements, when we go down, they can easily release an electron. It means that they can easily release an electron. Because all the metals releases electrons, they give electrons to the non-metals in order to complete the outer shell. So sodium is more reactive than lithium, because the electron of the sodium can easily escape from the outer shell. I'm going to show this kind of comparison from lithium and sodium. This is very important when you talk about reactivity. So the atomic number for the lithium is 3 and the atomic number for sodium is 11. Lithium has 3 protons in the nucleus. It has 2 electrons in the first shell and 1 electron in the second shell. And sodium has 11 protons in the center or in the nucleus, but sodium has 3 shells. So 2 electrons in the first shell, 8 electrons in the second shell, and only 1 electron in the third shell. As we look carefully, all these elements of the first group has only 1 electron in their outer shell. It means that they can easily release or give this electron to the non-metals. Now we are going to make the comparison which of these 2 electrons can easily escape from the atom. As we know, protons, which are positively charged particle, make an attraction, a force of attraction with negatively charged particles. So in the first element, lithium, this electron is very close to the nucleus. So it would need a lot of energy to escape. And for the sodium, the electron, which would be escaped, is very far away from the nucleus. So the electron, which is far away from the nucleus, can easily escape. What does it mean it can escape? It means that from this releasing the electron, the sodium would complete the outer shell. So we are going to write here minus electron. And what would it be like? It would be like this. 11 protons in the nucleus, doesn't change. 2 electrons in the first shell also stays the same. Here we have 8 other electrons in the second shell, but the third shell doesn't exist anymore because the electron has been escaped. So this is sodium element. The elements always has the same number of protons and electrons. And this is sodium ion positive. It is positively charged particle because if we look carefully in the second picture, we have 11 protons and 8 electrons. Electrons are negatively charged particles. So we make the summary. We would have 1 proton more than the electrons. That's why the charge for the sodium would be sodium positive. It means that it has less 1 electron because the electron has escaped. So let's go to reactivity of these metals. The metal of sodium is more reactive than lithium because it releases easily this electron. So if we go to the group 1A, from lithium to sodium, potassium, rubidium, and cesium, the reactivity of these elements increases as we go down to the group. Also, if we talk about the second group, also the reactivity increases if you go down to the group. But this summary, this information would work. It would work only for the metals. Yes, Daniel, lithium, it leaves the electrons. So for the elements that releases electrons or give these electrons, that would form positively charged particles. Positively charged particles, which we call them cations. So we call them cations. They have more protons. Number of protons is higher than the number of electrons. This is very important, this information about cations. And what about the activity of the columns which are in the right of the periodic table? I'm going to show you the differences in, for example, to the group 8 or to the group 7. To the group 7, we have fluorine, chlorine, bromine, iodine, acetylene, etc. These elements, as we talked in the beginning, are nonmetals. They are very reactive nonmetals. But what do you think about nonmetals? How do they react to complete the outer shell? I would need an information from you. What do nonmetals like fluorine, chlorine, bromine, or iodine, what do they do in the meaning of the electrons? Do they give or gain electrons to complete the outer shell? Would they need electrons to complete, or would they need to give or release electrons to complete the outer shell? I'm going to just make it more easily for you. For example, fluorine has the atomic number of 9. It means that it has 9 protons in the nucleus and 2 electrons in the first shell and 7 electrons in the second shell. So if we need to make to complete the outer shell for the electrons, Esteban Almeida, yes, they take electrons. In chemistry, we are going to use the word gain. So they gain electrons to complete the outer shell. And how many electrons does fluorine need to complete the outer shell? You can write on chat. How many electrons? Abigail, yes, 1 electron. Great. So I'm going to draw here 1 electron in red for fluorine to complete its outer shell. What would be the charge for fluorine now, after I added this electron, what would be the charge? -1. Esteban, great. It will be -1. Because if you look carefully, we have 9 protons and 10 electrons, which are negatively charged particles, and the summary will be -1. So if we write this as half reaction, fluorine would gain 1 electron plus 1 electron, and that would form fluorine negative. Fluorine negative is an ion. So fluorine negative is an ion. It is a negatively charged particle. It forms a negatively charged particle because it gains electrons. So as a summary for reactivity from forming these ions or taking and giving electrons, we would say that metals give electrons and non-metals gain electrons. And the metals form cations, and the non-metals form anions. Yes, but yes, like iron gives usually 2 or 3 electrons. But in the periodic table, some of the elements do not exist as single elements. They exist as molecules. We talked about maybe the previous session about the molecules, and the molecules in the periodic table, I would say that nitrogen does not exist as a single atom, but it exists as a molecule like N2. Oxygen also is O2, hydrogen is H2. Fluorine, bromine, iodine, it will be phosphorus. Phosphorus is P4, and sulfur is S8. These elements are molecular diatomic, so these are groups of atoms. These elements that I wrote here exist as molecules because they cannot complete their outer shell by themselves. So they need to collaborate with each other to form their outer shell. And for fluorine, I would write like this. Fluorine does not exist as an atom, but it exists as a molecule. So I'm going to write here F2. So one atom gains 1 electron, and 1 molecule of fluorine gains 2 electrons, and that would form 2 fluorine ions. That is very important to understand. What does it mean, like 1 molecule forms 2 anions? For the activity of the 7th group here, if it increases from up to the bottom, I would need an information from you. What do you think? How the reactivity of this group increases? It increases from up to the bottom or from bottom to the up? Reactivity of up to the bottom. Other ideas? Danny is very active here. Okay, so the definition is the reactivity of non-metals. Just listen carefully. The reactivity of non-metals increases from bottom to up to top, because the changes in non-metals is like this. The nonmetals needs electrons to complete the outer shell. They gain electrons to complete the outer shell. And the elements which has the smallest atomic number can easily take that electron from nonmetals generally. Just let me explain this difference between fluorine and chlorine. Here is the atom of fluorine. Here. So this is the element of fluorine, and chlorine, the atomic number for chlorine is 17. It means that it has 17 protons, 2 electrons in the first shell, 8 more electrons in the second shell, and it has 1 more shell. It is in the period of 3, so it has 7 more electrons here. So the chlorine also needs 1 electron to complete the outer shell, and the distance from the nucleus to the outer shell for fluorine is shorter, and the distance from chlorine to the outer shell is higher. So if I have one electron here, which is in red point, it would go easily to fluorine because the nucleus is very close to the outer shell. That's why the electron would go first here. It would not go to the chlorine because the chlorine needs a lot of energy to gain that electron, because the nucleus, which is positively charged part of the atom, that is the force that attracts the electrons, but that nucleus is very far away from the outer shell. So the electron would easily go to fluorine. That's why the fluorine is more reactive than chlorine. Also, chlorine is more reactive than bromine, etc. Okay, so this is the definition for nonmetals. The reactivity of them increases from bottom to up, to the top. And now the other thing that is important for reactivity is what changes to the nonmetals if I go from left to right or from right to left. So for this, we need to care about one of these periods. For example, the period of 2 here, the period of 2 is made by lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So if you look carefully only to the colors that you have here, it says that the reactivity of metals decreases because it goes from metals to nonmetals, and the reactivity of nonmetals increases because the number of electrons in the outer shell increases also. Here I'm going to take the example which you would remember very well. Here is lithium, beryllium, boron, carbon, nitrogen, fluorine. Here is oxygen and neon. So the atomic numbers are 3, 4, 5, 6, 7, 8, 9, and 10. So in these elements, the last element, which is neon, is unreactive. It is unreactive because it has completed the outer shell. So here is metal, metal, non-metal, non-metal, and non-metal also. So reactivity of metals increases from right to left. So the sign will be like this. This is the direction of increasing the reactivity of metals, and the opposite is for the non-metals. The reactivity of non-metals increases from left to right. So that would be the sign for increasing the reactivity of non-metals from left to right. Why is this definition for them? Non-metals tendency increases from left to right. Okay, great. Why is that, Danny? Do you have any information? Why does the reactivity of non-metals increases from left to right? My response would be like this. Just make a comparison between oxygen and fluorine. Oxygen has 6 electrons in the outer shell, and fluorine has 7 electrons in the outer shell. So oxygen would need 2 electrons to complete the outer shell. So 1 and 2, like this. And fluorine would need only 1 electron to complete the outer shell. So if the number of atomic number increases, if the atomic number increases, also the reactivity of non-metals decreases because of the chemical reactions. That is not a reason. The reason is if the nucleus of the non-metals increases, it means that that would be more force to attract these electrons. So oxygen, the nucleus for the oxygen and fluorine would be like, it has 8 protons, and the fluorine has 9 protons. So 9 protons makes more force to attract this electron. 8 electrons is weaker because it needs to attract 2 electrons. That's why the reactivity of fluorine is higher. Also, that would be a comparison for, this is for non-metals, how to explain this. And for the metals, just to complete this session, we have 5 minutes. For the metals, I would compare lithium with atomic number of 3 and beryllium with atomic number of 4. For lithium, we have 3 protons in the nucleus, 2 electrons in the first shell, and 1 electron here. And for beryllium, we have 4 protons, 2 electrons in the first shell, and 2 electrons in the second shell. So what does it mean, the metal to be reactive? It means that the metal would easily release its electrons. So lithium needs some energy just to release this 1 electron, but beryllium would need a lot of energy because it needs to release 2 electrons. And these 2 electrons are attracted a lot by the nucleus because the nucleus is stronger. It is number 4. So number 4 attracts a lot these 2 electrons. And the lithium has weaker nucleus. So this weaker nucleus do not attract a lot this single element, or this single electron. So this electron here would escape easily. So that's why the reactivity of lithium is higher than the beryllium. Just please remember these 2 definitions and this information that I gave you, because they are important for previous sessions that we will work on. If you have any questions, please.
Guys, if you have some questions, ask the teacher. Valeria say that if you can repeat again.
Okay, okay. So Valeria, we are here. We are comparing lithium with beryllium. They are at the period 2 of the elements. Here is lithium, number 3, and beryllium, number 4. I'm just making an explanation. Which of these two metals is more reactive? The metals which are more reactive can easily release their electrons. So here is the picture for the lithium atom, and here is for the beryllium, which has 4 protons in the nucleus, and lithium has 3, because the atomic number is the same with the nucleus number 3. The electron for the lithium would escape easily because it is attracted by a weaker nucleus. The nucleus for the beryllium here is very strong because it has 4 protons, and these 4 protons attract these electrons of the outer shell. So these electrons cannot escape easily because their nucleus is very strong. And the nucleus for the lithium is weaker. Let's say if you are at the house and the parents doesn't allow you to go out, if your father is very strong, it doesn't allow you to go out. And if your father is weaker, it is soft and just say, okay, you can go. So it means like if the nucleus is weaker, the electron cannot go easily. So the electron for the lithium goes easily like this because the nucleus is weaker. So here is, I would say, strong father at home, which doesn't allow children to go out. And here for the lithium, the weaker father allows children to go out. So it is weaker, and the electrons for the lithium goes easily, and that's why the lithium atom is more reactive. This would be the same if we compare sodium with magnesium, which are at the period of 3. If we compare potassium with calcium at the period of 4, etc. Okay. Okay, I think that's it. Lourdes, I finished.
Okay, thank you so much, Elidu. Excellent class, congratulations. Guys, congratulations again for your participation.
Bye, everyone.
Thank you, teacher.
Bye-bye.
See you for next class, okay?
See you.
Thank you, Elidu. Have a wonderful day, guys.
Bye.
Bye.